Good morning, students. To continue with solving gate papers questions, 2019 EC paper, a problem on AC circuit. So, AC circuit is here. It looks like outer delta. You have come across a delta and star transformation. Delta to star and star to delta transformation. Outer delta and inner star. And for this circuit, you have to find what is the current under steady state condition. What is the current under steady state current? Steady state current. Now, in this problem, involvement is with regard to impedance calculation. That's all. Impedance calculation and dividing the voltage by impedance give you steady state current. But at the same time, you are supposed to know star to delta transformation, because this inner star is to be converted to delta. This is called as star connection. And before I proceed with star to delta transformation, so first I will calculate impedance. So what is Xc? Xc is 1 by omega c. In this problem, omega is 1000. Therefore, 1 by 1000 and capacitance is 1 microfarad. If you calculate, it comes out to be 1000 ohms. Resistance is also 1 kilo ohms or 1000 ohms. So numerically same, but we have to convert this to, as you know that for capacitive reactance minus J notation is to be used. So we have to convert this to delta. In delta, it becomes how to convert this to delta. For example, this one. To get this, add these two and plus product of these two with product of these two divided by this. I will write here. To get this impedance, add these two. You are looking from this side. Minus JXC, minus JXC. You have added these two and take product of these two. Take product of these two and divide by this side impedance, that is minus JXC. This is repeated for these two impedances also. For this impedance also, this plus this into this divided by this. And for this impedance, this plus this into this divided by this. So impedances remain same. So if you simplify this, it comes out to be minus 3jxc. Minus 3jxc, that is minus 3000 j. Minus 3000. Xc is minus 3000 j. Now we have to fit this delta here. So taking out star, we have to fit this here. If you fit this here, it looks like this. It looks like this. Now you identify how many paths. This is one path, whereas this is another path. Now in the second path, I will simplify this and this. If you simplify this, you get, if you simplify this, you get, if you simplify this, you get 948 minus 19. 948 minus 19 ohms. This is also 948, 19 ohms. and this is also 948 90 ohms. Now these two are in series. Therefore, if you draw the network with impedance values, this is 948 minus 19 and this one is is 2 times 948 minus 19 degree ohms, because twice, that is 1896 angle minus 19 degree ohms. Now next, impedance of these two, that is ZT is equal to 948 into minus 19 into 1896 minus 19 divided by 948 minus 19 plus 1896 angle minus 19. You have to convert polar form to rectangular form in the denominator and then you have to add. If you simplify, you will get 0.63 angle minus 19 degrees ohms. Now current in milliamps. Current in milliamps equals, divide this voltage by impedance. Therefore, IT is equal to 2 by 0.63. 2 by 0.63 angle minus 19 degrees 2 sine 1000 t milliamps in milliamps. Now this is coming out to be 3.17 sine 1000 t minus plus, because it goes to the numerator, plus 19 degrees milliamps. Now answer is given in this pattern, but we are getting this answer. How to convert this to these forms is the question. Now first you interpret 3.17 sine 1000 t plus 90 degrees. It is to be interpreted like this. A phasor of 3.17 milliamperes, at an angle of 19 degrees, because plus angles are measured in counterclockwise direction. So this is reference. So from here angles are measured. That is why it is called as reference. So 19 degrees. So this is interpretation. Now to convert to this form, we have to take real axis and imaginary axis component. That's all. What is the real axis component? The real axis component is 3.17 cos 19 degrees sine 1000 t plus this one. Vertical component is 3.17 sine 19 degrees and vertical component is cosine wave, because cosine leads sine by 90 degrees. That is why cos 1000 t. If you calculate, it comes out to be 3 sine 1000 t plus 1 cos 1000 t milliamperes, and this is going to be the answer. Okay, in this problem you are supposed to know delta to star or star to delta transformation and then impedance calculation, and then phasor knowledge, the knowledge of phasors essential. So answer is 3 sin 1000t plus cos 1000t. Thank you.